Okay, I'm going to make a feeble attempt, hopefully successful attempt, to help you understand normal, inclined, and oblique surfaces. Okay? So I find these little dollar store things and I have them arranged so that they represent the three different planes. Okay? This one is the normal plane. And if I were looking at it from the front view, it would look exactly the right size and right shape. If I come around to the side view, now this is the one we're looking at, it just becomes a line. If I go to the top view and get it perfectly perpendicular to the top, it also becomes a line. This is called a normal plane. So this is my little glass box that I made. Okay, so in the front view, because it's parallel, it becomes true size and shape. So a normal surface will be parallel in one view, and in the other two, this is the top view. Let's see. It becomes a line, and that makes it perpendicular to that view. And in the, lost my side view. Oh no, where's my side view? Here's my side view. In my side view, it's also, where are you? Perpendicular, so it becomes a line. Okay, so a normal plane is parallel to one view, perpendicular to the other view, and where are you? Perpendicular to the other view. So it's going to be a plane in one view and a straight horizontal or vertical line in the other two views. Okay? All right, so the next one is an inclined line. And if you can see it, that's the middle one, it's leaning back compared to the other one, which is straight up and down. So it's leaning back, okay? It's not parallel to the front view. But when I look at it from the front view, it looks like a surface, right? But I also know it's not parallel to the front view, so it can't be true size or true shape. So it is inclined to the front view. Better not. Okay, so in the top view, if I'm looking straight down at it, where are you? Okay, it also looks like a surface. So make sure I'm on the right one. Got out too close. It also looks like a surface, but it's not parallel to the top view, so it's leaning back, and that means it's inclined to the top view. Now, if I can bring it over to the side here, a little too close. Okay, so you can see the pawn closest to you is the normal plane. It's standing straight up, or it's supposed to be. And then the middle one, which is the inclined plane, is to the side. But when you see it in the side, it actually becomes an inclined line, like that, okay? And that means it's perpendicular to, because whenever you look at something from the side, a surface from the side, it's going to be perpendicular, okay? So here's my box, and when I'm looking at it straight on, it's parallel. When I turn it perpendicular and the normal, it's a straight line. If it's leaning back like that, even though it looks like a rectangular surface, it's not straight up, so it's not parallel, it's inclined. And when I look at it from the top, it's also a surface, but it's inclined. But when I look at it from the side, it becomes an edge, and it's perpendicular. Okay. Definitely not cinematography things here. Okay, the last one is what we call an oblique line. If you look at it, it's not going to be parallel to any surface. When I look at the front of it, it's going to look something like that. And that's inclined to the front of it. When I look at the top of it, it's also going to be a surface, but it's inclined to that surface. It's not parallel to it. And when I look at the side of it, it's the same thing. It's going to be a shape, but it is not going to be parallel or perpendicular to those lines. So basically, when you have a normal plane, like this one, which is standing straight up, it's going to be a plane in one view, a line in the other views, and so it's parallel, perpendicular, perpendicular. When you go to an inclined line, which is leaning back, we got that leaning back, it's not going to be parallel to the front, it's not going to be parallel to the top, even though it looks like a surface, but when we look at it from the side, it's going to be an inclined line, and that's perpendicular. And then the last one is just going to be inclined to every view. It'll never be perpendicular or parallel in every view. So, and this can be in any view. For instance, if this is the way the line was, it's perpendicular, but when I look at it from the top, it's parallel, and then perpendicular from the side. So it doesn't matter what orientation it is in the box, it's those three orientations. And you have to remember a normal line is parallel in one view, which means it's going to be a surface, and then it's going to be perpendicular in two views, and the line is either going to be horizontal or vertical. The inclined plane is going to be a plane in two views. They're going to be foreshortened or inclined in both views, and a angled line in the third view. An oblique plane is going to be a plane in all three views. They're all angled to each view, and they're inclined to all three views. I hope that helps. I couldn't find a YouTube video to express this. So, okay, good luck.